Okay, so today we're going to go through the following question. Is the equation below a possible interaction? We're going to start off by looking at what these particles are, what they're called, and what they are made up of. So if we start with our P's, which are our protons, and you should know that protons consist of 2 up and 1 down quark. Our N represents our neutrons, and you should also know that a neutron is 1 up and 2 down quarks. Now the one you might not be familiar with is called a pion, and a pion is a type of meson, which means it has 2 quarks. Now this particular one has no charge because it's got a 0 next to it, and it could possibly be an up and an anti-up quark, or a down and an anti-down quark. And the reason we know this is because there is no charge, there must be an antiparticle that cancels out the other particle, the other quark in that main particle. Okay, so let's rewrite our equation that we are going to look at. And we're going to see whether this is possible. Now, there are 4 laws of conservation that you need to consider when you're doing this. So you need to know whether charge is conserved, whether baryon number is conserved, whether lepton number is conserved, and lastly, strangeness. Okay, and we're just going to consider those things very quickly. So first of all, charge should be nice and easy. You should know that protons have a 1+ charge, neutrons have 0 charge. Okay, so on this side, 1+ charge. And I said at the beginning that the pions, because they have a 0 at the top of them, they have no charge. Okay, let's just consider baryons real quick. So baryons are particles that are made up of 3 quarks. And we can look at the information from the beginning of the question to work out which of those are quarks. So protons, which of those are baryons? So protons have 3 quarks, so we can say, yep, that's 1 baryon there. Neutrons have 3 quarks, that is a baryon 2. Okay, right hand side of the equation, proton is a baryon. Now our 2 pions are not made of 3 quarks each, therefore they are not baryons. Okay, leptons. There are a few types of leptons that you are expected to know. The first type is an electron. The next is muons. And there are a few more, I'll just name them. Taus, the electron, neutrino, and the tau neutrino. Now you can see there that in our equation we have absolutely no leptons. Therefore, we can put our zeros in as so. The last thing to consider is strangeness. Now, strangeness must have a strange quark. and you can see that we do not have any strangeness in any of our particles. Okay, all that is left is to consider which of the laws are conserved, and if all of them, then we have a possible interaction. So charge, you can see that our left hand side of the equation has a 1 plus and our right hand side of the equation has a 1 plus. So we can say that charge is conserved. Baryon number, you can see that on the left hand side of the equation we have 2 baryons, whereas on the right hand side of the equation we only have 1. Therefore, baryon number is not conserved. Lepton number, all zeros on the left hand side, all zeros on the right hand side. Lepton number is conserved. And strangeness, no strangeness on the left hand side, no strangeness on the right hand side. So again, strangeness is conserved. Okay, now looking at this 4 laws as one, we can see that baryon number is not conserved. Therefore, this interaction is not possible. Thank you for watching, and I hope that this was helpful for you to understand this equation. Please do provide me with a little bit of feedback. Let me know if this is useful.